Good morning. This is Shubham Saurav, and I am presenting my project on servo motor control with gyroscope. So, first of all, we will see the circuit diagram. So, this is our Arduino board. We have used just Arduino board to supply 5 volt supply to this servo motor. So, we are using only 2 pins here, as you can see. This 5 volt pin and ground pin, we are using only those 2 pins, 5 volt and ground. Then we are making our this line as our 5 volt supply and the second line as our ground supply. Now this is our servo motor and it has 3 terminals, one for positive voltage, second for negative potential, and third for control signals. So this positive and negative terminals are fed from here, which is supplied from this Arduino board. So this Arduino board is just used to supply 5 volt supply, so that our servo gets sufficient current and voltage. Now these two are from Arduino board, these two are going to our servo motor. Now this third green wire is connected to our ground pin of our launch pad. So we are making a common ground, otherwise this servo motor will not rotate. Now next, if we see here, then control terminal of our servo motor is connected through this orange wire and it goes to PC4. And this is our sensor hub, which has gyroscope in it, and it has total 5 connection. One is for 3.3 volt supply and from microcontroller from our launchpad, and one is from ground. Then it is using one PB2 pin for GPIO interrupt and 2 PD0 and PD1 pins for I2C. So this is our whole connection. Now this is our terminal reading. So if we focus here, if we focus here, so these are our data which are getting. So here we are getting accelerometer values, here we are getting gyroscope values and magnetic field values. Our main focus is on this Euler's. So we have three parameters on Euler's angle: roll, pitch and yaw. So if I, for example, if I turn my sensor hub on this way, if my roll will change. So you can see here only my roll will change. So this happens just because of this. Now this is for yaw. So if I rotate this in this fashion, my yaw will change. And this is for pitch. If I rotate in this fashion, my pitch will change. So these three are Euler's angle readings. We are using this pitch, and based on the value of this pitch, based on the absolute value of this angle pitch, my servo motor will rotate. So I will try to turn it, and based on this value, as you can see, my servo motor will rotate. So as you can see, my servo motor rotates from here to here based on the value of pitch. Again I will show one more demo. So now I will rotate my pitch see, the servo motor is rotating. Now I will stop it and servo motor stopped. Now I will bring it back. So it is like that. Even if I go back and forth, it rotates. Now I have stopped, it has stopped. So this is our working. Actually the servo motor should be placed like this, so that it rotates with same angle as our sensor hub, but it is rotating in opposite direction because we have placed like that. Actually we have to place it like this only. So this was our project, and based on this our pitch value, here you can see our pitch is constant. So since our pitch is constant, our servo motor is not rotating. But once I make it minus 90 degree, my servo motor is in this position. Now I'll make it 0 degree. So you can see it is almost 0 degree, and my servo motor is in this position. Now I will make it plus 90 degree. So you can see on plus 90 degree my servo motor is on this direction. So based on the value of pitch from minus 90 to 90, my servo motor will rotate from 0 to 180 degree. So for 90 degree it will rotate 180 degree, and for 0 degree it will be straight like this, and for minus 90 it will rotate like this. So actually this position of servo motor is for 0 degree, this is for 90, and this is for minus 90. So my servo motor rotates in this fashion. This was my whole video.